Ok, parece que ya estamos grabando. Pues de nuevo, buenos días, Vittorio. Muchísimas gracias. Vamos a tener tu presentación y cuando acabe tu presentación tendremos una sesión de preguntas y respuestas y al final del cual habrá acabado esta parte de la actividad que luego continuará con una reunión interna del grupo después de una breve pausa.
Claro.
Por parte tuya, Vittorio, o de alguien en la reunión, ¿hay alguna pregunta del procedimiento antes de continuar?
O para mí todo es claro.
Muy bien. Me gustaría pediros a todos que hagáis el esfuerzo, si sabéis hacerlo, de cambiar vuestro nombre, al menos que aparezca, de hecho yo no lo tengo así, que aparezca al final de vuestro nombre cuál es el país al que pertenecéis. Alguno de vosotros ya lo tenéis. Pues muy bien, Vittorio, adelante, muchas gracias. Somos todo oídos.
Juan Alberto, Albert, gracias para invitarme a ese seminario y como dijiste, eso es un trabajo que hacemos junto con Dani Gafari de UNEP y otras iniciativas para tentar de reportar el SDG 14 y pues ahora voy a cambiarme en inglés porque es más simple para mí. Pero me tiene que perdonarme. Pues voy a tentar de hacer la pantalla grande. Pues voy a intentar de condividir con usted la pantalla, la que quiero de condividir. Yo creo que están viendo mi pantalla, la
Muy
grande.
bien. Sí, se ve perfectamente, gracias.
Sí. Ok. Pues, welcome everybody to this seminar. Thanks again for the chance to meet to show this work that we did in the last few years within the European and a collaborative framework. This is mainly what I'm going to do is mainly present this talk. The talk is mostly about presenting this paper. And I understand, Albert, that you already shared this paper with the group. And so you may be familiar with if you had the chance to look at it. So this group of people is the first portion from myself to Karina are several members of the Copernicus Marine Service between the Ocean Color Thematic Assembly Center and as well the Copernicus Marine Service offices in Toulouse. And then we have the second part of the list from Dani to Mengwa Wang are the colleagues at UNEP first, Dani, and at the GeoBlue Planet that were instrumental for the development of the SDG reporting scheme. And I'm going to tell you more. I just wanted to acknowledge all of my authors in this moment. So starting from the basics, and this is clearly not the meeting where I need to tell you what is eutrophication. So it's just that it's important here when we were writing this paper, we were confronted with the definitions. Eutrophication is a term that everyone knows what it is, but everyone has a slightly different definition of what eutrophication is. So it's also about knowing in which definition in which scheme we are basing upon us. In this moment, my favorite definition, and this is about favorites, is the Malone and Newton. The Malone and Newton is and Malone and Newton, I don't know if you had the chance to read, is a very nice review. By now, it's a few years old of eutrophication. I really recommend it if someone wants to read more. And is about increasing the supply of organic matter to an ecosystem that is fueled by anthropogenic inputs of inorganic nutrients. That then, and this increase in organic matter are due to excess in phytoplankton production. And this obviously builds upon and extends the Nixon 1995 archetypal definition where which is the one that most of us would be familiar with. Why I'm going here is because in a few slides I will show you what is the current definition that you use in the SDG, and is slightly different from these two. That's why it's important that to start by going along this one. Important. I don't mind having questions while I talk. If there are small clarification questions, ask them while I talk. I don't have a problem. Long questions and discussion, we can go at the end, but maybe useful if something really is not understanding something, stop me. I don't have a problems.
Let me translate that to be clear. Nos
Okay.
dice que si tenemos alguna cuestión técnica corta, que lo paremos para preguntarla. Como somos muchos, es muy difícil que yo vea la mano y dé paso. Si alguien tiene algo urgente,
sin mano, sin problema. Sin mano,
diga,
sin
que abra el micrófono y diga, no entiendo esto. ¿Ok?
Perfecto, gracias. Creo que va a ser mejor así. Bueno, most of this is a summary, and there is a lot of words of the introduction of the paper itself, and we do know, particularly in a group like this one, that monitoring the measure eutrophication, it's about mostly of the time is about chlorophyll concentration with other variable, but chlorophyll by itself is the most used variable used, and somehow, if possible, some information about nutrients are needed as well. Another important concept is that the expectation is that eutrophication is reversible. So there is an expectation that we can have impact on the environment if we are able to identify the sources of excess nutrients from the land and stop them. We should be able to to reverse eutrophication. That's really important because it gives us our monitoring effort can provide actionable information and can support adaptive management at coastal level and country level. So we can make a difference with this monitoring. That's an important point because that's the assumption that if you reduce the nutrients, eutrophication in the longer term should be reduced. So just to start putting some pictures, remote sensing ocean color data has been used since quite a while nowadays, more than a decade, to report eutrophication status. Important point, you will see that the word potential eutrophication is used, and the word potential comes if you're using only satellite and only chlorophyll. Potential is to just saying that we don't know, we don't have the whole picture because we don't have the nutrients. So that's exactly in the wording that we're using the word potential from the title of this paper onwards. But again, there are several papers, several methods based on the percentiles or basing on other methods where the classification of the ecological status has been performed. As I was saying, this work gets embedded in the official reporting scheme for measuring and reporting SDG 14 that was released by UNEP in 2021. 2021, there is, for the Sustainable Goal 14, Life Below Water, there is an aim by this year, so 25 is this year, no pressure, it's prevent and significantly reduce marine pollution of all kinds, particularly from land-based activities, including debris and nutrient pollution. And that's where we sit in this trying to report on 14.1.1a index of coastal eutrophication. And we have UNEP as our agency. Most of you would have or would know that all the SDG, each of the SDG reporting is done by one of the UN agency will have mandate to report and to get information. In this case, our relationship is with UNEP. So The UNEP report identifies a progressive method, a progressive monitoring approach from global data to regional and national data. So level 1 is the global reporting, and level 2 is the national reporting level. In both cases, the expectation then there is some measure of chlorophyll concentration, deviation, and anomalies, and also some information about the index of cost eutrophication potential, which is mainly based on nutrient data. And those are the two sources here. As I was saying, the definition and formulation of eutrophication for the sake of the SDG reporting is different from Malone, is different from Malone and Newton, is different from Nixon, and is about excessive nutrient loading in a coastal environment from anthropogenic sources, resulting in excessive growth of plants, algae, and plankton. The other important word is that the wording coastal environment refer to the whole national exclusive economic zone up to 200 nautical miles from the coast. So this is also an important point. All the reporting done in this framework has to report across all of the exclusive economic zones. Then, as I was mentioning before, GeoBlue Planet contributed to a draft methodology for the global product. And for this global product, the Ocean Color CCI, Ocean Color global datasets that are produced, that are developed based on a series of projects funded by European space agencies, and they are then produced by the Copernicus Marine Service and distributed by the Copernicus Marine Service year by year. They are used as the basis for this analysis. This work was working about using the report for European countries using the Copernicus Marine Service Ocean Color regional datasets. And as I said earlier, we are using the term potential eutrophication only because we are only using chlorophyll concentration by itself without, in this moment, making use of nutrients. Now, I thought that it makes sense to give you a few slides on telling you what is the Copernicus Marine Service and the Ocean Color Thematic Assembly Center that is going to use the data, that is going to be the source of our data. Someone with an open microphone, if they can put it off. So the Copernicus Marine, within the Copernicus Marine Service, we have an ocean color component that aims to bridge the gap between the data provided by the space agencies and the users by okay, now you can hear me. Juan, también usted está mutado. Okay, so the OCTAC provides data for as many essential osseous variables as possible that can be retrieved from ocean color radiometry, starting from chlorophyll, inherent optical properties, information on plankton, phytoplankton function type or size classes. And we have both global product and regional products to provide as much information as possible. The important point to make is that the regional ocean color products aim to provide the best, the higher accuracy than the standard products by introducing regionalization of the processing chain for basins where we know that the global products are not accurate enough. This is an example for Mediterranean, if only because this is the work that we do here in Rome, where we've been showing in the last 20 years global products, that the global products, which are shown as the black line, The green line are the relationship for the global products, which are not passing to our data points in this ratio, which is the same ratio of the standard approach to derive chlorophyll by NASA. In this case, we have to adapt our relationship, because otherwise the OC4V6, which is the standard NASA, is not able to predict adequately our own algorithm. So we did the regionalization, we improved our algorithms. We have an algorithm for blue waters and an algorithm for for coastal waters, and then our final matchups is as accurate as we are able to provide it.
Vittorio, that is a very important point, if I may ask you. So in your procedure, you are doing a recalibration or a reformulation of the algorithm for the chlorophyll A determination. You are not taking the standard formulation by whoever.
We are not using the standard for the standard ocean color CCI product, which is not the NASA standard, but is still overall a global product. We are, for this product, for Europe, we decided that we're going regional, because we have products that we know better, and also because the European taxpayers are being paying us to do things. We're trying to use the best information we have available. Good. If you don't have it, you revert to the global data. So this is an important point.
Yes.
And the reason for this one, Albert, is one. If you are going to tell to a country, you have to do something, that person who is going to ask you, how good is your algorithm for my waters? Because if it's not good enough, they're gonna just, you cannot have a conversation. That's really important point. Yeah. So thanks for making this point even more stronger. So just to clarify, and this is a slide, the important point is that each of the different regions have different algorithms. Each of the different regions have a story of us being everyone in the Ocean Color Thematic Assembly Consortium, having spent the last 15, 20 years knowing which is the best algorithm possible for the region and applying it. And there is an history of development. So for instance, this paper, which was on PrEP, was accepted today. So for the Arctic, we have a paper published today. So I'm as happy as.
Congratulations.
It was difficult, so I'm really happy about this one. And just to give you an idea. Then, having said that, this is a schematic of the method that we propose for implementation for the level 2, the one that is based on for European countries based on the CMEMS regional products. This is based on the figures on the paper, so says 1997 to 2020, but is now used every year. So could say 2024 because we do it every year, and I'm gonna get there. So what happens? We start from a basic. We have the daily chlorophyll value for all the time series at 1 kilometer resolution for all European countries, for the whole European region. Based on that, we calculate a per pixel baseline of the 90th percentile for every year, for every day of the year. We can then check whether how many days in a year the chlorophyll concentration was higher than the baseline. And then if at least 25% of the days are with valid observation, we can flag those pixels are potential eutrophication. Then we can do a few things. We're gonna count over the extended economic zone, how many of those values are reported, so that then we can provide a percentage of the area that is the potential eutrophication. Also, the other important point that we can also make a map. If we make a map, we can provide location of an alert, so we can provide those maps to help the countries to understand where something happens, and so how they can improve, what action they can take in place in the idea of this one being actionable information. This one is similar to a previous paper that we extended upon. The other part was then instead done also in collaboration with the Eurostat. Eurostat, the statistical organization of Europe, is the agency in Europe that has to report to UNEP. So there is a cascade of reporting that needs to happen.
Vittorio, a quick question about that. What baseline are you using for the P90?
It's here. You see, you were too fast. You didn't give me the chance.
Sorry.
So we used the fixed 20-year baseline 1997 to 2017, just as a standard. And so if new data arrives or there is reporting, we recompute it, but we didn't extend it for the time being. So a few points to reflect. We chose the 90th percentile of each day of each location based on 20 years. So that is site specific. It varies with the day of the year and is invariant from one year to the other. So we do know for a pixel that is 10 kilometers offshore from where I'm staying here, that what is the time series of the P90 for the year, and for every day I'm going to compare with the given day. So that P90, the 90th percentile, captures the phenology of that region, of that pixel. So I am site specific and I'm varying with the year. And the other important point is that we did the monitoring over the whole year, because a very difficult activity, particularly in a changing climate, is to define a growing season, because the growing season and the phenology has been shifting in the last 25 years. So having a high priori definition is also difficult. In the 20 years of the baseline, we expect the 10% observation by construction, a 10% of the observation of the P90. So we are going to raise that flag only if we exceed 25%. So if we really exceed more often than we expect the 90th percentile. And so nevertheless, we should be able to capture both the sporadic and sustained eutrophication event. The UNEP level 1 approach instead has a different scheme. The scheme is that there is based on monthly data and not on daily data. There is a different way in which the P90s are calculated, and overall, but at the end, overall important is that it comes with another indicator. I'm not going to give too much details because after 5 years still I don't understand it exactly how it's done. The important point is that the P90, which is the reference, is computed for each year. So there is no stability in the P90. It's a global and not a local P90. So there is something that, my understanding, UNEP and GEO are changing. And the baseline is only about the mean. So there is no variability around the mean for this accounting. So these are some issues that we identified for some caveats for the UNEP method. Let's go to the results. First part, we have a time series, we have the daily pixels, we have the baseline, and we're gonna count, and we arrive with a pixel that has flagged as potentially eutrophic. So we come with a map. So this is example of the figure published in the paper, where we say this is the map of 2020. Based on the data from 97 to 2020 for the eutrophication, where more than 25% of the observation were above the 1998-2017 P90 reference. And you see here that we have quite a lot of red, where we have some red, and also very interesting, we also have a lot of blue. So we also show regions where there is an active oligotrification, which instead of being higher than the 90th is lower than the 10th percentile. It's another, because we count both, because we can, really. Because it doesn't cost us more. That's the very simple. The very simple reporting. The gray lines that you see are the extended economic zones of each of the countries. And so you will notice that some countries have very large economic zones. Some countries have economic zones with a lot of blue waters. Some countries have very small economic zone only in coastal waters. And I hope you see my mouse here. So it's going to make a difference of how much you expect a country to have higher value or value. But because sorry, my daughter is trying to reach me, so I need to send her a message. Okay, sorry. So this is what this is as you do, and then based on each of these regions, you're going to do statistics for the reporting. So, for instance, if we look at, let's do one simple one, Portugal. Portugal is, we're going to count which portion of this region here as red to be able to give a number for that region. So, and that's what we do now. The important point, and this was about trying to do a bit of showing a bit of the science, how this map is coherent with our expectation, our understanding of the biogeochemistry of the basins. This one shows that these high values of potential oligotrification for the Mediterranean Sea as well the Black Sea is consistent, for instance, for the chlorophyll trends that we report within Copernicus for those years, and in the meantime has been extended, where we show that quite a lot of the basin has a decreasing trend. So it makes sense to expect, particularly here in all this portion where the trend is in the order of 2, if not 3% per year of decrease over those 23 years, then this one gets mapped as a year where 2020 was particularly looked like oligotrophic. Then otherwise, for instance, the same is true for the North Atlantic, where some of the anomalies in these regions are coherent with this area here. So this area here is coherent with the chlorophyll anomalies for 2020. So compared to the average value of the climatology of the same 20 years that we use for the analysis. And the same is, for instance, if we look at the trend as a plot and not as a map. So this is coherent. This blue here, that it's also coherent that most of the basin for 2020 was appearing as oligotrophic. Then the second part, as I was saying before, if we are here and we are in Portugal, we have these many pixels where we have to tell you how much is this red part, which is the part that where apparently we identified semi-eutrophication. So what you do is for each of the countries, we go and count what is the portion of the areas that is to be reported, and then we prepare this table where we have all the countries in alphabetical order. And for instance, I showed you before Portugal in 2020, which was this value here that was in the order of less 3.2 or 0.3% of the area, because as an example. So a few comments on this map, and this is on this table, and which is represented graphically. And again, I'm summarizing what is written in the report. So several countries the important point to start, you see a lot of dark blues. Dark blue means that it is low, very low or nil exceedance of for less than 1% in the extended economic zone, and in the second portion of the reporting, they were overall low values, while in the first portion of the reporting there were some high values here. For example, important to show is in 2007, 2008, we have some countries, and Denmark, Lithuania, Latvia, Poland, and Sweden, and somewhere there is also Finland here, where you see these high values. These are two known years where we know that in 2007, 2008, we had extended spring blooms and extended summer blooms in the Baltic. So it's consistent with our understanding of the system. This is something that we occurred, so it makes sense to see these red data points here. The same is, for instance, in the second part of the decade, there was a big study done by modeling, biogeochemical modeling, and ensemble analysis for European seas, showing that there was a reduction in eutrophication in the second decade compared to the previous decade of the study, and also the same applies for the Atlantic countries and for the reporting for the Baltic countries. Then if we do the same analysis with the UNEP level 1 map, and we have different values because the computations are different, and so the way the ranges are reported, the two figures are not directly comparable. And overall, the patterns are coherent, but the numbers are different. This is just as an important point to make. For instance, in here, you're gonna see again the Baltic country that are the ones that have really shown high values in the as in the previous analysis done with the regional products, and there is also here some of the potential reduction, but some values are still high, and we felt that this one is highlighting more potential eutrophication with the method base that we propose for European waters. Then what happens? And this is where it becomes exciting, particularly for me. We wrote a scientific paper. We wrote a report. We sent a table to the European Environmental Agency, that sent a table to the European to Eurostat, so the European Statistical Agency, and magically a number appears in the report, in the official report for Europe, of what is the eutrophication for Europe. So this method has been uptaken for the official reporting of Europe. And this is the report for 2021, the first time that Europe came and produced a report about all of the progress towards all the Sustainable Development Goal reporting. And this was the data for 2019, the one for the paper. Then the following year, the same data from the paper was used also for reporting on 2020. Number which was similar, because if you do an average across all the European disease of Europe, this is 0.2. Then in February 2023, we extended the time series. We in the meantime, I should have said more clearly, now every year, if and when if we need or if we have more evidence, we update our ocean color algorithms, we recompute the time series, we extend the time series, and so we release new data sets. So we compute everything again, and in this particular case, we did some changes in the algorithms, and for 2022, looked like that the values reached 1% for the European, for the country. Last year, we did it again. We extended the data up to 2023, and the value was better than the previous year. The important point to make it every year, if we make changes to the ocean color data, this report changes. And this is particularly important if some of the sensors that we use are included or not in the time series. So there are a lot of reasons why they can change. And last week we sent the updated version of this table was sent last year for the computation, including 2024. I don't show it yet because we are still checking with our Eurostat colleagues. Also, the very important point to make is this data is publicly available on Eurobase. Eurobase is the European, is the Eurostat data browser. So all the data about all European Union statistics are in this Eurobase, and the data is publicly available there. So if someone wants to make numbers and make their own graphs and look at them for the analysis, the data is available, publicly available there to do for further use. So starting the summary part also, because it's more than half an hour that I'm talking to you. This method is cannot identify the cause of eutrophication by definition, but we are just identifying area where there is a phytoplankton growth that could identify the eutrophication. It's about identifying events at 1 kilometer resolution, and is about providing satellite identification to also identify area that needs further work to monitor and to control the nutrient input. This is a summary of the conclusion in that paper, where we identified a few issues that still could use and could change. So there's nothing is perfect. You know, you do it once and you go for it for a year, but there are some changes that one can do. For instance, should we use the whole year, or we should change to a growing season defined in some years? The numbers are going to change. Should we change the way we chose of providing the observation, the 25%? What do you do if you have areas where it's too cloudy, so you don't have enough observation for the reporting? There is an issue with the upwelling areas, and I'm going to give you some information on upwelling areas that is particularly relevant for South America. That what happens with the upwelling areas, because the upwelling areas are giving you chlorophyll, which is not due to land-based nutrients. The spatial variability, how make use, and what is, how do you propagate the uncertainty of the algorithms, chlorophyll algorithms, on a daily basis on this reporting and we do. There is a lot of things we don't know and we still have to be able to work with. So as an example, I mentioned the issue of the upwelling region. As an example, and a few of you may have noticed when I was showing before, in this region, and this is the region where we have most of the upwelling that we interested in reporting, there is some potential eutrophication in 2020 for Portugal, Spain, and Morocco. This high chlorophyll and hence this reporting is likely to be due to the upwelling events that by definition are erratic in when they occur in space or time. We know they're going to occur here, but every year they will occur a week later or a week afterwards, some 50 kilometers to the east or some 50 kilometers to the west. So they are not going to be. So we need to remove the data that we know is due to upwelling because it's unfair for that country. And this is clearly the issue that is, this is exactly what I was showing, the Portugal to northwest, but the same applies to a lot of the South American coastline. So it's even more important for South American to work on how to address this issue. Having said that, and I'm coming to my conclusion, within the context of the SDG 14.1, Blue Planet contributed to a first methodology. In this work, I presented the methodology proposed by Europe for the European reporting, for all the European countries, done all of them in the same way, and using the in a harmonized, consistent, integrated matter for all European countries, the Copernicus Marine Service Ocean Color Regional Dataset. And as I've been showing, the data is uptaken by Eurostat as a contribution for the European Union contribution for SDG reporting. And I'm finished. And thanks for your attention. Preguntas.
Thank you very, very much, Vittorio. I think there are many things we need to think about and talk about, pero ahora sí voy a cambiar a español. Yo tengo muchas preguntas, pero voy a dejar el espacio a todas vosotras y todos vosotros para que hagáis preguntas, comentarios, establecer un diálogo con Vittorio, porque yo creo que tenemos muchas cosas que aprender de él. Pues adelante. ¿Quién quiere empezar? Hay que romper el hielo. Siempre es lo más difícil. No empiezo yo.
No sean tímidos.
Sí, no sean tímidos. Ya veis que Vittorio es una persona muy abierta. Ánimo. Bueno.
Bueno, yo puedo preguntar algo. Sí.
Bravo,
sigo, ya que pregunté al principio sobre la línea de base, el baseline de los 20 años. ¿Hubo algún tipo de discusión para elegir el periodo? O bueno, tomaron 20 años porque bueno, era lo más atrás que podían ir con el satélite. ¿Y hubo algún tipo de discusión o de análisis como para ver si esa elección de esos 20 años es suficiente para evaluar la utilización o si ocurrió algo en alguno de esos años que pueda hacer que la evaluación tenga cierta complejidad o si podría ser mejor?
La primera parte de la pregunta es ¿por qué los 20 años? El por qué los 20 años es porque nosotros tenemos también este indicador, que es el indicador del trend, ese indicador aquí, que es el indicador de la anomalía. Las anomalías también en el ámbito del Copernicus Marine Service adoptó los 20 años, 98-2017. Es una forma de consistencia interna, si tiene sentido. La definición y la selección de los años es un problema, claro. Y también los 20 años nos dan la esperanza que, porque son 20 años y tenemos que hacer un P90, no es un P90, son que son dos valores en los 20 años, porque eso es el problema. Si tiene 20 años, el P90 son dos valores. Pues es un límite, claro, pero eso es lo que tiene. Pues ahora que tenemos 25 años, del 98 al 2023, ¿qué vamos a hacer? ¿Vamos a computar todo otra vez? No lo sé, porque otro aspecto de cambiar metodología y que tú tienes que comunicarlo al usuario. El usuario, cuando le cambia algo, te va a preguntar, ¿y por qué cambió? Y para nosotros, cuando les decía que aquí en los 3 años las figuras cambiaron, porque aquí cambiaron porque no los computaron algunos valores aquí, cambiaron. Y cambiaron porque nosotros creemos que en el algoritmo del Báltico, en esta serie, le cambió el algoritmo. Pues yo creo que es la mejor clorofila que te puedo darte. Y pues voy a cambiar todo. Pero es difícil decir que era el 0,2% y ahora el 1%. Porque, ¿sabes? Es un problema que puede ser también problemas de comunicación con los políticos, con la pi grande. Eso es parte del problema.
Bien, muchas gracias y muy buena la presentación.
Gracias.
¿Alguna pregunta más? Ánimos. No sé si a la
Elena, creo
y
que está...
algo, pero tienes el micrófono apagado.
Disculpe.
Ya.
¿Ahora? ¿Sí?
Sí, perfecto.
Sí. Tengo una duda que no le he podido resolver y obviamente porque quizás no esté en el objetivo del estudio, ¿no? Y es que en todos estos 20 años también ha habido un incremento de la temperatura que ha sido significativo y es una variable que nos pudiera estar, que sea una variable autocorrelacionada en este caso y pudiera estarnos marcando el incremento y de esa tendencia en la clorofila. De
Eso,
manera que
no,
nuestro discurso hacia los
es un
políticos
problema
pudiera estar
claro.
un poco...
Alan, es
¿Sí?
un problema claro, es que no estamos todo está cambiando y pues, y pues si haces la baseline, si haces la baseline hasta el 2017 y
Ah,
vas a ver lo que es el 2023, porque si se anda mirando
ah,
a los años en la baseline, ese 20 años, no tendría, no tendrías gran problema. Son los años los años más recientes que son lo que tienen el problema. Pero el problema es que eh, la, la agua más caliente va a cambiar la data, la datas del bloom, la fenología. Cuando, y puede ser que en algunas regiones la clorofila es más baja, en algunas regiones la clorofila es más alta. Pues no es lineal, eso es el problema, que no sabemos cómo sí y cómo son los efectos, porque el efecto en cada lugar es diferente, la respuesta de la fenología del plancton al calentamiento. Eso
gracias,
es,
gracias, sí,
eso
cierto.
es, no, ma eso es un punto llave del reporting. Ese reporting del SDG 14 no tiene la palabra clima en el reporting, pero claro, estamos en un todo que está cambiando. Eso es un problema.
Capite, capite. Gracias, gracias.
¿Alguna pregunta más? Bueno, yo tengo un comentario y una pregunta, Vittorio. Nosotros somos un, un network, una red de investigación costera. Y entonces cuando hablamos de algoritmos para clorofila, ¿no? Pues a todos nos produce cierta inquietud porque, pues como tú sabes, los algoritmos de aguas abiertas no funcionan tan bien para las zonas
Claro,
costeras, ¿no?
claro.
Entonces, esa es una pregunta. ¿Qué nos recomiendas? Porque tampoco es que tengamos tantos datos como los que hay en el Mediterráneo, ¿no?
Ah, ma eso non son tantos. Esos se parecen tantos, pero no son tantísimos.
Vamos con nuestros países sí son tantos.
No, eso es un problema. Claro que es un problema. Un, hacer un trabajo de evaluación y validación de los algoritmos y los productos globales que están disponibles para las aguas de cada región es una llave. Pero si tú eh, eh, puede parecer loco, pero si tú sabes que aquí, un ejemplo que yo sé, en el Alto Adriático, que es uno de los 5 áreas que Malone y Newton identifican con las 5 mejores áreas de eutrofización del mundo, aquí, eso el mar Adriático aquí. Nosotros sabemos que la clorofila estándar está 20-30% más alta de lo que tiene que ser. Más o menos siempre. Si es más o menos siempre más alta, y tú haces un reporte con el P90, poiché va a ser un problema de reporting relativo, puede ser que no es tan un problema. Puede ser que no es tan, no es pero puede ser que para ese reporting que es relativo, no es tan problema. Claro, si tú tienes la habilidad de andar a desarrollar los algoritmos regionales y la cadena de procesamiento regionales, va a ser más cierto y puede transmitir la certeza al operador político, porque ese es el problema. Si tú sabes que la tu clorofila no es adecuada para tus aguas, pues es un problema. Eso es la llave. Y pues la necesidad de la regionalización y la necesidad de usar cuanto menos los algoritmos que sean utilicen los optical water types, las clasificaciones. Haz un ejemplo. Eso es el método simple que usamos en el Mediterráneo. En el Mediterráneo usamos tres clases. El agua blue, los casos 2, el agua costiera, que es más o menos el Adriático, y el caso de Bloom. Son los tres casos. Más o menos el Mediterráneo es casi todo agua blue, 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 blue. Azul, azul, azul. Pero algunas regiones costeras es prácticamente el problema en Italia. Pues, si yo voy a decirle al gobierno italiano que tú no puedes usar un algoritmo estándar que no es bueno aquí y para el agua costera no trabaja, claro que no van a ser tan contentos. Pues, tus dudas son claras, son sensatas. Eso es la llave. La llave es tener habilidad de mostrar la validación y puede decir, tengo algoritmo regional, tengo un algoritmo de optical water type que trabaja bastante bien. ¿Cómo voy a hacer? Por ejemplo, el algoritmo de Ocean Color CCI es un algoritmo con 8, creo, 8 o 10 optical water type. Pues no es el simple Ocean Color V6 de NASA que tiene un algoritmo para todo, ma es que va utilizando diversos algoritmos para diversos tipos de agua. Puede ser que es mejor. O ahora EUMETSAT en abril o en mayo va a darnos un nuevo algoritmo de clorofila que va a utilizar 16 optical water types con una ambición de de trabajar adecuadamente a los 4 orden de, de magnitud de la clorofila. Eso es lo que dijeron, eso es lo que mostraron en algunas reuniones, en webinar, en esos meses. Pues la evolución de la cadena algorítmica ahora hay soluciones que pueden ser válidas. Eso es lo que voy a intentar de decir.
Muy bien.
Pero Vittorio, aún en las aguas azules en caso 1,
¿Sí?
ustedes utilizan algoritmos adaptados para las
Sí,
regiones, no usan.
porque en el caso del agua azul del Mediterráneo, la tinta de azul del Mediterráneo no es la misma tinta de azul del Atlántico y del Pacífico. ¿Por qué? Porque una serie de hipótesis, porque no es un océano, ma es una vasca de baño. Eso es el problema. Pero es una, porque no sé se lo recuerda, está en un paper que a mí gusta moltissimo, que es un paper del CETO del 2011, que mostró por la primera vez como todos los océanos son arriba o abajo de la línea de Ocefor. Eso es la que si tú haces con una sola línea, tú quieres cubrir todo, no puedes hacer. Y eso es el motivo por el que ahora utilizamos mucho los optical water types para poder cubrir y ir en todos los casos de agua.
Muy bien. Ok, Fernanda. A ver, otra pregunta de mi parte. Esto, pues, es una cosa que tenéis montada para Europa, ¿no?
Claro.
Y está financiada por la Unión Europea, etcétera, etcétera, ¿no? Bueno, entonces, para que entiendas un poco cómo trabajamos en Remarco, te lo voy a decir cómo es, que es nosotros tenemos, cada país tenemos unas zonas de estudio
Claro.
independientes que integramos los países y los países son los que tienen que reportar, ¿no? Y eso luego tenemos la red donde compartimos, aunque de momento no se ha planteado un reporte global, pero podría pasar, ¿no? Es decir, vamos desde la escala local a la regional. Ese modelo que vosotros estáis usando y está operativo, ¿no? Porque cada año entiendo que lo estáis volviendo a correr, es fácilmente implementable a cualquier escala, a cualquier lugar, o solo sirve para vosotros.
No, son dos. Cuando la primera parte del problema es la clorofila. Cuando tú tienes un producto de clorofila que está bastante contento, eso es la primera hipótesis. Cuando tiene la segunda parte, que es andando el contar le cose, eso es una banalidad.
Yeah.
Son algo como son 100 líneas, son 100 líneas de código en Python. No es nada de complicado, eso son 100 líneas de código que podemos compartir. Eso es el simple. El simple es cuando tú tienes todos los datos en tu NSDF perfectamente empilados, pues tiene que son contas de la simple, no es
Sí,
no, no,
es contar
no.
píxeles. Ujú.
Sí, eso que
Lo que pasa, sí, lo que pasa, Vittorio, es que aquí en el grupo tenemos desde países donde no hay experiencia en productos satelitales hasta países que hace tiempo que están trabajando, ¿no? Tenemos un rango. Y de hecho, en un futuro no muy lejano, pensamos organizar un curso donde se expliquen y donde se nos enseñe a hacer, pues, determinadas cosas, ¿no? Pero por eso te decía yo, sí, adelante.
Eso para mí es claro, límpido, es claro y límpido. Y fue la razón fue porque me dio gusto aceptar la invitación de hablar de esa charla, y que yo hoy personalmente, y yo sé que muchos de los colegas, tenemos disponibilidad a darle cursos, a tentar de encontrar una manera para poder ofrecer un curso que puede ser del Ocean Color y del reporting, que puede ser una semana o lo que sea. Pues eso es importante, que yo vengo a darle la charla, no por darle la charla y decir, aquí lo hacemos, aquí lo hacemos, vayan. Tengo la disponibilidad a explorar con ustedes
Muy
como
bien.
grupo y como network, como red, cómo podemos ayudarlos a transferirle la conciencia, darle forma para hacerlo ustedes y o hacerlo nosotros para ustedes en alguna manera. No tengo idea cómo es la manera, no tengo ideas cómo vamos a hacerlo de los dos lados del Atlántico y un poquito del Pacífico, pero eso es un interés, claro. Tenemos maneras para transferir ese know-how. En particularmente porque uno de los proyectos en quien soy en ese momento es un proyecto que es financiado da EUMETSAT y se llama Copernicus Marine Training Service. Pues, esa base del Copernicus Marine Training. Eso puede ser el momento para hacer identificar cómo vamos a hacerlo, si podemos hacerlo, para haber bastante resources, porque una, dos, tres personas trabajan desde Europa para haber una semana con ustedes para hacer un curso. Eso puede ser, puede ser algo que tentamos planear para el 2026, 27, o lo que sea, para tentar de dar esta actividad. Pues para mí es una de las razones por que acepté la invitación.
Muy bien, muchísimas gracias. Y qué bueno que lo hayas dicho delante de todo el grupo, ¿eh? Que no es solamente una conversación. Esto nos comentaba Dani, y ya con esto, perdón, acabo porque ya nos estamos excediendo mucho. Nos comentaba Dani que no hay un manual aún desde UNED, ¿no? Para adaptar lo que se está haciendo a nivel local y nacional. Pero en realidad no creo que sea muy cierto eso, ¿no? O sea, esto es escalable a cualquier escala que uno quiera, en realidad, ¿no?
Sí, eso es el problema es como decía antes, es que, como decía antes, es que el método estándar oficial de UNEP, de UNEP puede ser que va a cambiar un poco.
Ujú.
El método estándar de UNEP, no sé si los datos fueron extendidos pues del 2021 o algo. No sé, no sé en dónde están. Yo tengo la tabla hasta el 2019 porque fue esa es la que recibí cuando estábamos escribiendo ese trabajo, pero no tengo idea. Los pasados 2 o 3 años no encontramos bastante para saber cómo es. Em, eh, pero yo creo que probar a ver si este método tiene sentido con el algoritmo global de CCI a los 4 kilómetros en el aguas que sea todas las aguas de Sudamérica o que sea unos dos países que es un esfuerzo que es un proyecto que tenemos como darle forma para transferirlo. Eso es lo veo importante.
Muy bien. Pues no sé si hay alguna pregunta más. Voy a detener la presentación. ¿Puedes dejar de compartir o yo puedo pagarte? Ah,
No,
yo creo
no,
que
aquí
ya,
es.
ok. Quería, antes de que nos despidamos, os quiero pedir a todos los que podáis encender vuestra cámara porque querría sacar una fotografía de la reunión. He ido sacando alguna, pero a ver si podemos tener la mayor parte de los participantes que nos veamos. Hay muchos que no están, igual se han ido a tomar un café o alguna cosa así. Bueno, pues vamos a tomar un par o tres de fotografías. Muy bien. Vittorio, de nuevo, muchas gracias. Creo que tu presentación ha sido muy buena, para mí muy clarificadora. Me ha gustado mucho y yo creo que... tenemos más cámaras encendidas. Voy a aprovechar para sacar otra, perdón. Bueno, y todos los que podáis también podéis sacar alguna imagen de pantalla. Te decía que, yo creo que nos vamos a comunicar más en el futuro y gracias por tu tiempo y por tu interés. Creo que lo has dicho muy claramente y creo que incluso tu mención al training de Copernicus es una puerta interesante para el futuro también. Y pues me despido y a los demás os pido, ahora son las 10:15
Bueno, un comentario volante.
Adelante.
Si tenemos un interés de trabajar para hacer un curso, puede ser importante si me escribes unas pocas líneas en los días que vienen para que pueda iniciar este conversaciones desde el lado MZ del proyecto.
Ok.
Porque creo que no es tan difícil. Eso es lo que voy a decir.
Ya,
Puede ser.
muy bien, muchas gracias por ese ofrecimiento y yo en los próximos días, probablemente después de la reunión, te escriba para describirte un poco lo que desearíamos que
Claro,
tuviera el curso.
claro. Y si en los meses que vienen qui- quieren otras conversaciones para intentar de dar forma a cómo ese reporting puede ser puesto en pie en Sudamérica, yo soy ampliamente disponible.
Muy bien, de nuevo, perfecto. Estamos todos muy contentos. Muchas gracias. A todos los demás nos vemos dentro de 5 minutos. Ahora son 1:15, pues a la 1:20 nos volvemos a ver. Muchas gracias, Vittorio.
Vemos. Buen día para todos. Chao, chao.
Gracias.